All right, welcome back. Hopefully you all enjoyed poster session. And of course, there'll be more mingling and whatnot afterwards before we close out shop here. But I'm very excited to introduce our closing keynote speaker, Alok Pattani, a developer advocate, Google Cloud, focused on generative AI, data science, sports analytics, very much has a passion for generating insights from data and practical AI tools. He's an expert in sports analytics, having been a founding member and a leader of ESPN sports analytics team. So we have a nice bookend today, opened with Dean, closing with Alok. Since ESPN, he's joined Google, and he actively provides data science consulting services to both teams and leagues, and has a great public presence in the sports analytics field. So let's give a warm welcome for Alok to close us out.
All right. Can everyone hear me? Sweet. Okay.
This.
Awesome. Thanks, Ron. Yeah, super excited to be here. It's been my first time here at Carnegie Mellon Sports Analytics Conference. Learned a lot. It's really exciting, and hopefully we can keep the momentum going through this closing keynote. So earlier today, Dean in his keynote said, AI can't help us. And I love Dean. We work together. I have a lot of respect for him, but I'm going to have to disagree. I think AI can help us, and that's kind of the subject of my talk. He might have been talking about Allen Iverson. I might be talking about artificial intelligence, whatever. A little bit of background on myself. So as Ron mentioned, I work at Google. Most of my focus the last several years has been in Google Cloud in a developer advocacy role, which means I talk to technical practitioners about how to use our tools, in my case, mostly for data science and generative AI. I've been involved in sports partnerships there, and as well as making demos for sports, some of which we'll talk about here. Prior to that, I did my bachelor's and master's in statistics at BU. This was before there was data science. And even before machine learning or AI really took off by a lot. And then, as Ron mentioned, founding member of the sports analytics team, which was very exciting. We worked on a lot of metrics across sports. And then outside of Google, I do consulting with organizations like the Dallas Cowboys and the NCAA men's and women's basketball committees. Outside, another thing I'm known for, I guess, is ice cream. Super passionate. There's an ice cream dashboard of all the places I've been to in the US. There's an ice cream agent, and we'll talk about AI agents. That was the first agent I built. Shout out to the Milkshake Factory and Dave and Andy's, which I've both gone to in like 36 hours. So we can talk about ice cream later. Today, we're going to talk about generative AI and sports. Just give some background on how I see generative AI, what the applications are to sports, of which there are several. And then we'll go through 3 different examples, one with MLB scouting reports, one with a data extraction challenge, and one with AI basketball coach demo that I've worked on with a bunch of folks at Google over the last several months. Wrap up and have some time for Q&A. I think, how many of you have played around with AI in the last 2-3 years? Okay, almost everyone. So, this is just to set the table. I'm sure everyone's pretty familiar with this. I think I kind of came on board to the AI team in Google Cloud right around the time GPT came out, and we started to get a lot more interest. So I've kind of rode that wave for the last almost 3 years. And this is kind of the way I think of it. Generative AI is a type of artificial intelligence that can create new content, text, images, audio, video, learning patterns from existing data. And then the key part is the generating similar but original output, right? So sort of pre-generative AI, I think the first part was true, learning patterns from existing data, but you're not necessarily outputting original output. It would be sort of like these more quantitative predictions and things like that. And then ways I kind of think about generative AI, again, I don't develop this, I just use the technology and see how it works is, it's a human-like collaborator, can understand language at a high level. So whether that's to help you generate code or to, talk through different permutations or do research. And then this one, I stole, I think from Sam Hinkie, where he said AI is like infinite interns. So you basically, have a project that's a lot of rote sort of like transcribing or something, AI can help you with that. So you might give that to an intern, but what if you had like 100 interns or like 1,000 interns? Or like interns that are just really fast. So it's like, this I could do, it's not that hard, but instead of taking an hour, it might take AI like 5 minutes to do it, right? And then the intern analogy, I think, holds up with like a lot of these AI tools. Like, I think we're all aware they're not fact machines. They're not 100% accurate. So like an intern, you might want to check the work and, iterate from there. And a lot of the initially, like, from like a data science perspective, it's like, what's the input, what's the output? So I think of like generative AI as like this, way to basically move between any output. So if I have a podcast, but I want a summary, I can do that, right? So audio to text. If I have a bunch of text and I want a podcast, I can go that direction too. And the same is true for sort of images and code, right? We can understand, we can output. So it allows, I think, a real like amplification of all the types of activities and things you can do, outputs you could not have thought of before. So how can we do this in sports? I try to think of the data science process. There's lots of different tools we use, things we have to do to get from that sort of raw data, or even maybe no data where we have to generate the data, all the way to the insights and sort of the outputs we want. So from my perspective, like data science coding, how many of you used AI for coding in any sort of environment? Okay, I think this is like the most sort of useful unlock that I've experienced in the last couple of years. I often now work in Google Colab, which is a Jupyter Notebook tool from Google that has like kind of AI tools built in, increasingly more. And now like I find myself still writing some code and reading it, but often just prompting, getting code, running it, being like, okay, I need to fix this. And it's a whole new kind of way of development. And I think some of you probably know many more tools than I do and are more advanced on this. So, I have some demos on this, but I'm not going to talk about the coding aspect today. The middle three sections, so data extraction, analyzing unstructured data, and creating new data and insights, those are the things, the examples I'll go through today. You can see some tools that I've listed out here, and I'll go through in more detail. And the last one, sort of this like personalization element. So a lot of, I think, the focus when we do sports analytics is around teams, leagues, analyzing players, all in the context of like, let's make better decisions. Let's draft better, these sorts of things. I think it's also important to note that there's a large amount of folks, at companies I worked at, ESPN, Google, where we're very interested in using, sports content and differentiating that. And I think generative AI provides a huge way to sort of personalize content and at scale in a way that was not possible before. Okay, first example, I'm going to talk about searching through MLB scouting reports. So this is, the concept here is in baseball, there's tons and tons of data on players. I think some folks have talked about that in their presentations today. Quantitative data, awesome. We know what to do with it. We can filter, sort database. We can build models. We're great. But in baseball and in many other sports, there are scouting reports often like this, where there's lots of rich information in text data. Right, and this is a random scouting report from a player that I picked up from, and when I collected these, just so you know, it's from early 2024, so it's actually a month before Paul Skeens got called up. So this was a scouting report that was on public scouting report on MLB.com. And imagine that, teams will have thousands of scouting reports on players from all different levels, minor leagues, college, other teams, all sorts of things. And, if you wanted to sort his age, height, and fastball velocity, you might be fine. But what if I wanted to look at the information within this scouting report, but actually across all scouting reports, right? So it's not traditionally as easy to mine as structured data. What can we do with sort of generative AI tools here? So again, I work at Google, so I'm going to talk about Google tools. I'm aware that there are other ways to do this too, but the idea is, you can do this. So I have a tool called Vertex AI Search within Google Cloud, which allows you to create sort of a Google search experience, but only over your sort of structured data. So if you have your proprietary scouting reports, it's a pretty easy setup. You click some buttons, you point them at a Google Cloud storage bucket with your scouting reports, and now you have basically retrieval augmented generation, which is go find the right scouting reports, and then maybe give you a summary of the ones for whatever question. So I'm going to try this. Demo gods will hopefully be with me. This is just a preview of what this looks like within the Cloud Console. So let's say I want to look up something pretty simple like 5-tool players. So I search this, right? And like I said, so we'll pass on this top result, the generative result. Even if I just look at the results, it looks kind of like what Google search does, but they're all PDFs from my data store, right? And it's like, okay, this guy has 5-tool potential, Scouts give 5-tool prospect, the 5-tool skill set. Okay, so that's pretty good. But you're like, dude, I can just write Control F. Like this isn't showing me anything I couldn't do before, right? I can search for 5-tool in a scouting report, right? So let's try something a little more complicated. So one I've tried is like relievers with significant movement on their fastball. So maybe you can quantify this at advanced levels. You certainly can, but maybe we just have text data, someone describing each pitch that a pitcher has. So if I do this within a couple seconds, right, I get this summary. And what I think is important is you get the reference to the scouting report, right? So we know, again, that these tools aren't perfect. I think the models are getting better. Hallucination rates have dropped a ton since the initial release of this. But what the key is here is that it's not just going to look for the words movement in fastball, right? It's going to semantically map that to different terms that could refer to this. So in this case, it says, oh, this guy's two-seam fastball has a lot of run, right? So what does that mean? Well, hopefully it means that there's thing, and then there's more sink than ride, some sink and can bore in. And again, I can look through this, go there, be like, okay, yes, did it say that? I can verify for myself and go find the passage. So something that maybe isn't easy to quantify, I can now search through, again, 1,000 scouting reports in seconds to answer these questions very, very quickly. And then for like the last one, so this was, right, so like, what if you have something more, even more sort of qualitative, right? So top practice injury concerns. So maybe in my database, I don't actually have a field for injury or type of injury, but I'm curious about who are some guys that have injuries that I should be aware of. Maybe I need to surface these to my medical staff to vet these guys before I think about drafting or trading for these players. So again, you have those scouting reports and then boom, just like this, right? And it doesn't look for just one injury. It'll be like, oh, this was a knee injury. This is a hamstring injury, lumbar spine inflammation, torn labrum. All these sorts of things are surfaced to you super, super fast. So again, we're used to doing this with quantitative data, right? With filter, sort, dashboard, these sorts of things. Now with text data, I think you're starting to see tools that make that as easily accessible. And I think like this sort of technology could be applicable to any sport or any kind of use case where you have a ton of like organized text data where again, you want the stuff. You don't want it to go search the internet necessarily for this. You want to look just within your organization's data, PDF scouting reports. So let me go back here. Yeah, okay. So next up, wanted to talk about another sort of problem in the data process. So we're going to talk a little bit about PDFs, but it's a little bit different. So how many, for whether it's a sports project or elsewise, have ever had to like scrape data or take something kind of unstructured and try to figure out a way to make it structured? Okay, so almost everyone again, and so have I. And how many of you really enjoy writing that scraping code that you have to do for that? All right, Samir, my guy. So you can shut your ears off for a few minutes here, right? So this is where I'm going to introduce sort of the concept of agents, right? So we talked about generative AI, and in the last year, certainly in my world, or maybe a little longer, it's all about AI agents, right? So what differentiates kind of a generative AI model or a tool from an agent? And I think this is a definition from a colleague that I like. It's that the agent uses the model, but it makes some sort of decisions, acts independently, and it's trying to achieve a goal, right? So it's not necessarily just input, output. It's like input, do something, and then maybe output or take an action somewhere else. So, the key is and I'll use quotes here because they're AI, but they're going to reason, they're going to plan, they're going to execute these tasks. They interact, so you can't have a human in a loop where it's like, hey, I did this, what do you think? Okay, and then it takes the next step based on that. It utilizes external tools. So the library of these sorts of things you can do with agents is growing really, really fast, right? So you can call your own functions, you can call functions that other people have written, you can connect to databases using things like MCP servers, and you can connect to other agents using protocols like agent to agent and these sorts of things. And the key, again, is that it goes beyond the sort of simple input-output from generative AI. They can do more. Another way I've heard about, from a business standpoint, is AI agents will be the way that enterprises and folks can actually generate the value out of the LLM, right? The LLM is a super powerful technology. The agent is the way to tie that into your business. And again, intelligent workers you can delegate jobs to, these sorts of things. Okay, back to our initial question. So let's say we have useful data. So that's great, but it's only in PDF form. So this is an example I got from working with the US Olympic and Paralympic Committee, USOPC. I had been chatting with them over the last year, and I was like, oh, cool, you should do all this crazy stuff. And they're like, we have PDFs. I was like, that sounds terrible. So this is examples of figure skating and skiing results that they get. And this is their database, for better or for worse. So step one is just extract this data into some sort of form that would be useful, right? And then we can go do analysis, but right now we're blocked on this. So we talked about this a little bit, and I got some help from them on this. And we built an agent using the Google Agent Development Kit. So this is a new technology that we launched. It's open source, so that's kind of cool. In April, it allows you to build agents. It's model agnostic, so yes, of course, we'll say use Gemini, our world-class model. You can use it with other models, including open models or models that run on your computer. It's deployment agnostic. You can deploy it in Google Cloud. Of course, we prefer that. You can also deploy it elsewhere. It's compatible with other frameworks. I am by no means a software engineer. Not a chance. But I was able to build a couple agents here with some effort, but it abstracts a lot of the work for you, and you can just focus on a lot. Honestly, a lot of my agent code is text instructions to an LLM, if this, do that, or do here, go here, try this, that sort of thing. So I built a pretty simple agent to handle our Olympics data, but also more generally solve this PDF data extraction problem. So as we talked about, agents get access to tools. In this case, my tools are two functions that also themselves call LLMs. Excuse me. The first tool is to get the table schema from the PDF. So we have that PDF, which is semi-structured, right? It has tables in there, but it's kind of just going to go in as text. And what we want to do is extract it into a specific format. That will help us for analysis, right? So that tool is going to reason about the format of data to be extracted, and it works with user input. The second tool is then going to take the schema we generated and then actually do the extraction and pull that out into either CSV or JSON format. And it uses a process called controlled generation or structured outputs. Super, super underrated, I think, a tool of an LLM. So usually an LLM, text in, text out, obviously text in, image out also too. But text in, data out, data frame, right? That's super underrated. I don't think it's talked about enough. I think it's awesome. Use it all the time. So this code is available publicly on GitHub. I can share it now or later. And all of this with the two tools and the root agent is about 300 lines of Python code. But again, a lot of it is just text, long paragraph instructions and stuff. So this is available to be used if you want. This takes a little bit of time to demo, so I'm going to show screenshots just as a time-saving metric. So we have this figure skating data we were talking about. It has different levels of results for each skater. So maybe it's a little hard to read, but it has their total score and their rank up here. And then it has each of the elements and then each of the scores and then judging scores for each of the elements in here. So maybe you don't want all this. Maybe you just want the top line results. Maybe you just want each element. And you can do that. So here, I basically hey, can you extract this schema? So this, again, is meant to kind of be an eye chart, but you can see it extracts this JSON schema that's very detailed, nesting, all this stuff. And then you can go back and forth and say, hey, I'd rather, don't give me all this. I just need the top level, or I do want this, or change the name of this, change the format of this. So you're just interacting natural language. You get this schema. Then you pass that schema, again, with the original LLM, with the original PDF to the other tool, and then it will generate this data, just as you see here with each element, the judges' scores. And, so we tested this out. I sent it to my colleagues at USOPC and be like, hey, is this accurate? And it was like remarkably accurate. Now, this is a nice, well-structured PDF. Maybe like you have more that are not as digital friendly, but this is like tremendous. And again, we didn't write any scraping code. We did specify things to the models and to the agent, but we didn't have to write the code ourselves. So, this is pretty big unlock in a lot of places where we don't have data. We can do all the fancy analysis once we have it, but we don't even have it. So I think this is a place where something like generative AI with an agent can help, turn the sort of difficult into a more possible first step. All right. Next thing we're going to talk about is this AI basketball coach demo that I was talking about. Watch this fun little marketing GIF that people, not me, made. So we like to do sort of cool things. We have a couple big conferences at Google. One is called Cloud Next. The other one is Google I/O. And we like to have demos of like real world AI technology to like inspire people to think about it differently. And we like to do like some are more serious. Shooting a basketball is more fun. So we did this demo where you go into like sort of a cage. There's about like cut out a basketball court and you shoot a free throw. We analyze 5 different aspects of your form and then give you coaching feedback on that. So obviously a lot of different pieces have to come together for this. And we'll talk through them a little bit here. So the key here is like, it's fairly low tech. Obviously, there's a lot of sort of pieces that have to come together, but we're not assuming that you have Hawkeye cameras like they do in MLB or NBA. If you have that, awesome. They are specifically trained to capture this sort of stuff. They are also super expensive, only installed in the top sort of, top league level or the next level of arenas around the world. So we did it with 3 to 4 Pixel 9 phones around the court. So you can see here, there's an arc camera, a form camera, and then another form camera kind of here facing. So depending on the metric, we're looking at each of those cameras is useful, right? So the one from behind can track the ball the best. The one in front of you can track some of your arm angles and stuff the best. And the one from the side can track your sort of knees and toes and that sort of angle as well. So a little more detail on how it works. So the Pixel camera captures every angle of the form, and if the ball went in, of course. And that footage is recorded on device, and then it goes to cloud storage. The 2 key parts here is the combination of Gemini and what's a technology called MediaPipe. So a lot of you are familiar with traditional computer vision. MediaPipe is a computer vision library that is available to do this stuff on device. So on the phone itself, it can compute skeletal tracking, ball tracking, and position tracking. That's super useful because we wanted this to be pretty fast. It wasn't quite real time, but after the person shot, we don't want them waiting like 20 minutes for their feedback, maybe 4 minutes, 3 minutes for their feedback. So we have skeletal ball position tracking. What does Gemini do? Well, in theory, we could ask Gemini, did they shoot well? I'm not sure it's like specifically known for this. So what Gemini does is help process the video for the frame we want to send to MediaPipe. So we asked Gemini, like, where were they in their crouch? Because that's actually not like super easy. So you could write some rules-based algorithm to be like, oh, the crouch is when their knee is like as much forward, as far forward as it goes. But actually, what was easier, more successful, is like ask Gemini to take the video, slow it down, pass to Gemini, say which frame is the crouch, and then pass that to computer vision to get the pose tracking that you want on that frame. So that's kind of the combination of those 2 things. Then we compare that to sort of ground truth data we got from general, like there's basketball sort of on rules on the internet in terms of like, hey, here's the optimal angle. Steph Curry has a master class. We worked with the Warriors for some advice as well. We have a partnership with them. So that all comes together, your data versus like the kind of ground truth where it should be. We give you scores, and then we also give you coaching on how you can improve. And to be clear, this is for the amateur basketball shooter, like the tech conference basketball shooter, so maybe even below the amateur level. So much so that you'll see here, this person who shot also was ranked #1 that day. Now, maybe that was an initial day of testing with only Googlers, but you don't know that. So you get different scores for elbow position, elbow height, knee bend, arc height, entry angle, and we had sort of different aspects for each of those. So in my case, my arc height was 11.9 feet. The ideal is something like 13. So I got a little bit less of a score, and we say, you should enter the angle here. How to do that, kind of like lift your elbow up above your eye or something like that. So again, these are pretty generic shooting tips. But like it gives you an idea of if you put a bunch of these things together, what can you do, right? And you only need, traditional smartphones for this. You don't need special technology. Again, it's not for like the highest level, but I know like baseball teams that spend millions of dollars to build this sort of setup at a high tech level. So can we, democratize that down to lower levels, use sports even in your own backyard? And I think these show that like this sort of thing is sort of viable these days. And sort of the last piece of that was that we had this cool opportunity, recently announced a partnership with the best shooter of all time, Steph Curry. So I was a little nervous about bringing this to Steph Curry's camp because it's like, I don't want to be telling Steph Curry how to shoot. Like none of us should be doing that. But he was good about it. He hosts an annual camp where he invites some of the best high school men's and women's basketball recruits to come to the Bay Area for like all sorts of stuff. So the first day we had this as kind of like a fun welcome event. So he did it, and his staff was actually super into it. They were like super competitive before. And then he did it. One of the staff members beat Steph on the first try, and he was like, not having this. So then Steph did it. It was awesome. And then the campers came through, and these are actually hoopers. So their scores were much higher than we had seen at the tech conferences. And I don't know, like, again, I probably wouldn't mess with their forms either. But the type of thing you have here is like, if you had repeated analysis, you could basically get within your norms. So it's like, oh, I now know my elbow angle. Like, it doesn't have to be what the coaching says. I don't need that, but I know that mine should be here. And if one day I'm out here, like I have tracking on this, I have telemetry on this. So it could be used at higher levels as well. But this was fun. They blurted out, rightfully so, but I was standing here in the back. Okay, so final thoughts. This is my only AI image. I forgot what I prompted it with, but this was funny. It was like, why is it like a swirling staircase and then there's a robot on top? But I think big picture, I think AI can kind of help with all different, almost every aspect of sort of the sports analytics process, right? So we talked about data collection from video or camera phones. We talked about data collection from PDFs. We talked about analyzing that data, unstructured data in a way that we couldn't before. I didn't get to all the other things with like coding and stuff. So I think AI can kind of help at every step in the process. There's some parts where you might be more or less comfortable with it. I think that's totally fine. It's just about matter of finding the right problem where these tools can come in handy and start to unlock or speed up or really push forward the boundary of what we can do with sports analytics. So thanks. There's a few links here. Feel free to connect with me elsewhere. And I think, Ron, we do have time for some questions.
Yeah, plenty of time for questions. Let's thank Alok. And if you have questions, please raise your hand. And all right, we got hands up.
Hey, as you said, for converting unstructured data to structured data, for example, of email to a data frame, and I couldn't come with an better example. So if you are taking customer refund email, and you want to convert that to a data frame where variables like the customer ID, phone number, and name, and the reason which product they are returning. In that all email, you take that email, give it to any LLM, and give it in any schema you want for using any Pydantic or anything. And then if the LLM gets confused between the product, if they mention two different products, but their inside meaning was they found a better product and they named that or something like that. If LLM how reliable is LLM of picking the right product and putting it in data frame? And if you do that with huge data sets, if you cannot check each one by one or something, how reliable is that for using?
Yeah, so I think I have a couple answers to your question, if I understand it correctly. So I think one, within the schema you provide, you can also provide like an enum that says like it has to be product A, B, or C. Your point is like, well, maybe they'll still confuse B and C or whatever, and I only allowed to pick one. So like a lot of it is still, you're going to need to like know what are the possible things that'll come through in your email and what do I want to map it to. As far as eval, I think like, yeah, the idea of like eval at a large scale is a huge like open question with LLMs and generative AI in general. I think there's more tools for that. I think a lot of it to me is like the combination of sort of traditional data science techniques and LLM. So you're like, okay, like how often should this product appear in my thing? And you have some intuition around that. And then you run it through a bunch of emails. So you can spot check a few, but you can't check all of them. And then you would just like map it against that distribution in your head and be like, okay, it should come up 10% of the time. Oh, it came up 50% of the time. Probably something's wrong. And I think a lot of that is where I would, again, kind of, your subject matter. That I think is still important. And then how do we test what we're getting out?
Another hand up here. There we go.
So I had a question on the AI basketball coach. So
Yeah.
Does the AI basketball coach sort of push players to have like the ideal form, quote unquote? And would, for example, Steph may have his in his form or something. So would it push players towards that? And then do you see a way for that AI basketball coach to sort of improve somebody's jump shot just based on how they shoot themselves? Does that make sense?
Yeah, it does push to an ideal form. Like the scoring is basically all based on like, hey, your knee should be exactly above your toe. In some cases, people are not bending enough. Some people are bending too much. Your elbow should be between 80 and 85 degrees. So a lot of people are like out here, right? Things like that. So yes, and like I said, this is again for a demo use case for people who have like never played basketball or haven't played in a long time or coming and shooting, and it's kind of like the advice is generally going to be useful for them. Like some of them, their arms are out here, they're shooting underhand, right? For actual sort of basketball players, I think you could tune the model to be like more some of this is just comparing to numbers, and like the key is the computer vision gives you the numbers to compare. You could have sort of personalized ranges or things for sure. Yeah, so.
Thank you. It was enjoyable talk. I'm most interested in ice cream in Pittsburgh and your reviews there.
Okay, sure. I haven't uploaded the data to my ice cream agent. It's just in my head right now. So like the Milkshake Factory was super cool. I like that a lot. Dave and Andy's had a high hype level, and I'm not sure it quite met that, but it was still good. Like my scale on ice cream is what I call the like, I think it's like Jeff Van Gundy, like NBA coaching scale. So it's like good, great, Hall of Famer, right? So I'm like, it's pretty hard to like say the ice cream was bad. I probably have like 2 or 3 of those across hundreds. So I don't think you're gonna be disappointed, but that's my review.
Hi, awesome talk. Really enjoyed it. Curious about the AI basketball coach as well. Was this like kind of just providing advice for a standard jump shot, or like could it provide advice for if you took like a step back or like turn around, like fadeaway type shot? Yeah, if you could just expand on that at all.
Yeah, this was very kind of dialed in for free throws. So like a little bit easier for us to control the measurables there. There was like a game mode at our first version we did it, which I thought was more fun, but that was basically tracking just like distance. And it was like a shot distance scoring. So it was like, oh, you shot from here, so you get more points or whatever. It certainly could be used for all these different things. At the highest levels of sport, you have this level of tracking. Hawkeye can do that sort of stuff, post tracking. But yeah, this is just for free throws for now.
Thank you for your talk. It was, I really liked it. It was very informative. I just have one question again about the AI basketball coach. How well can it, like, I know that especially players like in like high school and like in those junior levels, like I know that like they may really change like how they throw the ball if they're like under a lot of pressure. So I'm wondering like, is the AI only trained for when you have zero pressure on you, or like is it also trained for like when you have like somebody like covering you, or just like or even like a double team on you? Like what situations is it trained in?
Yeah, like I said, this is very tuned to like free throws with no defense, the controlled environment. That's a little bit easier. But I think and Dean could probably speak to this too. Like in coaching, there's certain cases where you want to rep the exact like game situation, and then there's certain cases where you actually want to extract out all the sort of variables and like let's focus on this player's form, and like we can dial it in and make sure like we get that really good over many, many, many days. And then ideally that would of course translate to the game, but we're actually like going to kind of strip it down and measure these more granular things, and then hopefully they'll of course come into the real world whenever that happens.
We have a question in Steinberg. Okay, I got nothing from them. Any other questions?
I put him to sleep, Ron.
Hi, so I was just wondering, for the AI basketball coach, are you just looking at like the position of the person, or are you also looking at like release speed and like spin of the ball?
Yeah, I think we'd love to do more tracking than the like 5 metrics we had. So it was like post tracking that gets you kind of 18 points on the person, and then the ball arc. So I think release speed would probably be doable. Spin might be hard because it has to get like a higher level of granularity. So but like we had like a list of all these metrics we wanted, and then we pared it down to like what was actually working. Yeah.
Do you have like a number 2 sport that you would want to apply this AI basketball coach to? Like not basketball because this is basketball centric, but maybe use the same technology on like soccer for PKs or some other sport.
Wonderful. Well, before this, we did soccer for PKs. So I just didn't talk about it. That one was a little bit it was like more fun and less like kind of dialed into like critical feedback. It was, you take a PK. So we had like soccer net, PK spot, and then like 2 bins in each corner. So it was like either you hit to the top right or the top left corner. And we evaluated accuracy, style, and power, I believe were the 3. So again, computer vision can say like, and we could even do this pre-generative AI. It was like, where's the ball relative to the top bin? Speed was actually, to your question, we can measure the ball speed. So that was actually good. And then style was just like, we tried a couple different things, super subjective, but we did that. Some colleagues that I did not work on this had an AI swing coach that like even Bryson DeChambeau tried. So they've had some success with that. So I think we brought it to a few other sports. I don't have like a particular one. I think it's interesting. Any place kind of where you want to democratize the ability to collect the data.
We all have the opportunity to know how bad our golf swings are.
Yes.
I'll say one more question. Time for one more. All right. Got another one.
Thank you for the talk. Unfortunately, my question isn't about the AI basketball agent, but I'm more interested in the AI agent itself.
Yeah.
I was wondering, like, in your development process and also when you're advising clients, how do you strike the balance between kind of keeping things simple enough and feasible that you understand what the overall pipeline is doing and also leveraging the full kind of potential of these kind of technologies?
Yeah, I come from data science background, worked in sports at ESPN, probably had like 1,000 lessons of like everything I did was too complicated. So like at least to explain. So we try to like get it down to the level of like, you can explain what an agent does without like uncovering, I'm uncovering some of these tools and things because we're a technical audience here. But you can explain this without that, right? And if you can do that, I think you might have the perfect match of like, it can be as complicated, built out, crazy machine learning data processing pipeline here. In the end, we're predicting something that is like very attuned, or measuring, analyzing, summarizing something that's very attuned to like what the decision maker, the whatever coach, GM, fan is looking for. So I think that's kind of the sweet spot where you can do that. In general, I try to lean towards simple. Like my agents are super simple. There's no multi-agent system here. Eventually that level is needed, and I think you bring that in when it's needed, but I try to start at the base level.
All right, let's give one more round of applause for Alok for his fantastic talk. And Alok is also going to go home with a Carnegie Mellon Sports Analytics Center pullover, so we can all match, right? All right.
Thank you.